All right. First, I want to apologize for the confusion with the homework one. I didn't really wanted for that to happen at all. So for those of you that I have joined, I want to apologize because I created the videos and I've created the homeworks. Then I realized after I posted it that the problems didn't match the video. So apologize, and I'm going to be really lenient on it and not going to grade all parts of it. So I apologize if that has caused any confusion on any of your behalf, and I sincerely apologize for that. So
okay.
On an apology note, I did make sure that any of the videos you will watch and anything you will do from now on will have no mix-up of whatsoever. Okay? So I do want to apologize for that. So I'll open the house for questions. So does anyone have any particular question on your mind that you want to? Now this session was purely optional. I created it because I don't want to be completely in the dark and not have to, put everything as video and figured if more people join, they will all have their questions and you can actually chat as well. So if you have questions, you can also type. And I'll be able to answer any questions you might have. And I also have my virtual pen ready. If you can all see it, virtual pen. So if you have questions, I'd be happy to write them as well on the screen. So, but does everyone able to hear me well?
Mm-hmm.
All right,
yes.
Very good.
Yes.
So as I said, starting week 2, week 1, I also teach in-seat classes, and we're pretty much all on the same boat. So the first week you can consider it, if you have not caught up to everything, that's quite all right. I don't think really much has happened since school started last week. But I do want you to, as I said, every video that I have posted up until week 3, every quiz homework is being perfectly aligned. You will have absolutely no problem. And what is covered in the video is what's on the homework card. Okay?
So are we to go ahead and look at the videos for week 2 to try to understand the questions on the homework that we don't understand, or?
Yes, just don't worry about homework 1 at all, okay? I am not going to really grade it that hard at all, okay? Starting week 2, okay. Larkin, right? Which one do you want me to call, Lowell or Larkin?
Lovell is my first name.
Okay. All right, Lowell. I don't want you to worry at all about homework 1, okay?
Okay.
Okay, because there were questions, again, they were supposed to be in week 2. And again, that's probably what caused you some hardship, and I sincerely want to apologize for that, all right? And so if you have seen some questions on homework 1 that you were not totally sure about, don't worry about it. As you open week 2 videos and look at the homework 2 and quiz 2, everything will make promise, okay?
Okay. What about the quiz for week 1?
I'm gonna just take it easy on both the quiz and the homework for week 1, okay?
Because I was totally with you up until I got to the 2 miscellaneous videos.
Okay.
I really thought I was getting it.
Okay. Yeah, the miscellaneous videos you can also use for week 2. I'm going to send out a separate email. So week 2, let's say that we're starting a class on week 2. How about that?
Okay.
Week 1, we're going to consider both the homework and the quizzes. I'm not going to value that much as far as the grade goes for those. Okay.
Okay.
I'm not going to put a lot of emphasis and grade it very hard. I would not do that. Okay. I take my word for it. Okay.
Do you want us to attempt them?
Still attempt them because it's practice. Because I want you to get used to taking quizzes online and get that practice. I still want you to try them because then you know, okay, this is how you want me to tackle things. Like I want you to make those attempts and really get. But you do need the knowledge from the videos from week 1. Let me make that clear. Okay, you still need to understand the material presented in the week 1 videos, because those information is fundamental to understand week 2 material. Okay. I still want you all to watch week 1 videos because there was absolutely nothing wrong with the content. Okay. The content was presented 100% accurately. There is no error whatsoever with the content I presented. The reason I create these videos, I could have easily referred you to a YouTube video. Actually, the way the course itself was structured was purely like textbook reading, okay? It was scanned copies of the textbook, and there were homework problems just on the back of the book that you would solve. And you and all of us will have no connections whatsoever. Everything was already designed, the exams, quizzes, everything. When I looked at those and I was imagining all your faces, virtual faces, and you would just be really overwhelmed. You would not be able to read 35 to 40 pages of material. Chemistry is not that, I'm not saying it's impossible, but it's not that easy for you to just read a couple of pages in a textbook and without any guidance at all be able to do. There were 25 problems each week on the back of the book. There is no way no human being could do 25 problems, read 40 pages, and be able to do the quiz and the homework and the exam all on their own. It was more like a buffet setup where I will not even see you ever. I would just monitor that you're all present in the class. That's the way it was structured. And I felt that's not how I ever taught an online class. And I felt it total unfair for me to say, all right, I will see you every now and then occasionally interfere and ask any questions. So the way it was initially structured was there would be absolutely no connection between you guys and me. And you would just open each week and do it. And that's when I started creating the virtual videos. That way I can tailor the material to what is happening that week rather than have you read pages and pages in a textbook and try to make sense of it. I have taught chemistry at various levels, and I've also tutored several students, and you need some kind of scaffolding from an instructor at some point to really make sense of chemistry. You cannot just read a book and try to make sense of it. So I want all of you to still watch week 1 videos if you have not, just to learn the content, okay? I can send more practice problems for week 1 if you want me to, but I am not going to be really hard on the homework or the quiz. But I don't want to just say that because then nobody will make the attempt on it, okay? You see what I'm saying? People won't take me seriously if I tell you I'm going to cancel homework 1 and quiz 1, then nobody would watch those videos, then the videos become of less value. The videos have absolutely no error whatsoever content-wise. You do need to watch every one of those videos because when you get to week 2, it's scaffolded. Every week videos I've recorded, it is scaffolded and tailored. I did not go by the book, or if you've been to any typical chemistry class before, week 1 you'll be learning significant figures or a lot of math, okay? You obviously saw no math because I believe in conceptual chemistry and learn chemistry in a way that makes sense to you. And I know a lot of you are going to be in the medical profession, and I value that because your services, I will be using your services somewhere down the road. You might be my nurse. So I wanted to thank you. If not, I'm going to be in trouble. So I do value your service. But I don't want you to learn chemistry as a math, okay? You're going to be a nurse. Yes, you do need some math in your chemistry, but you don't want to be just plugging numbers in calculator and spitting out numbers to me. I don't want you to see chemistry that way. And I spoke to a couple of the nursing faculty before I created some videos just to get some tips on what they would like to see their students. Some of you are nursing, right? Nursing students, right? And so I have created down the road, you will see specific activities that are relating nursing to the chemistry aspects of it. So you won't just see me give you quizzes or homework that's all about numbers, like plugging in, getting me a number, no, I don't believe in that, because that's not how you learn. Maybe that's the picture people have painted as far as chemistry goes. But so don't worry about homework 1 and quiz 1, okay? Because of that confusion, I am not going to be hard on any of you, even if you got a perfect score. I'm gonna just treat it as a separate entity for now and not worry about as part of your grade for now, okay? I am not going to technically include homework 1 or quiz 1 for now. For time being, I can still use some of the points you've got. In the end, you needed points, but I'm not going to treat homework 1 and quiz 1 at a level that I normally treat. Okay, I hope that puts your mind at ease, because there was that confusion, and it is unfair for me to treat it too high to a point where people are not going to get the true benefit out of it. Okay, it's all about, I value the learning. I don't get caught up in grades, and so that's why I'm giving you attempts on quizzes. Typically, most online classes or even in-seat classes, you get only one single attempt on quiz. That's it. Hi, can you hear me?
Yes.
Okay. So don't get caught up with homework 1 and quiz 1.
Hello.
Let's go easy on it. Okay.
Yes. Go.
But here's the take home for it. I do want all of you to watch every video in week 1, because when you start week 2, I would have said, okay, previously, and I reviewed every material. If you don't have,
This is my class.
having fun, huh?
My grandson, sorry.
No problem. But what I'm saying here is, I have covered week 1 video in depth. I gave you all the basics you need to know to be really successful with week 2. So even if you don't want, even if I'm not going to say, even if I come out and say I'm not going to grade homework 1 and quiz 1, I still want you to watch those videos, because you cannot walk into week 2 without any basic idea of whatsoever on week 1. So that's where I wanted to have this meeting. We can have it every Saturday if most of you are interested. Does this time work for most of you? I know some of you work, but I do it on a Saturday because everybody's a little bit more relaxed than doing it on a weekday.
Yeah, I have a question, Professor Kumar.
Yes.
I mean, I watched all your videos and actually made notes and stuff. And on some, I actually thought that the videos were really good. So I have to tell you that, because I probably took chemistry back when, God, a long time ago when I was in high school.
Okay.
A long time ago. So this was like really good, because it, I kind of understood, step by step. So I have to kind of commend you on the videos, which helped me personally a lot.
Okay.
So if we still have some questions like on the videos and stuff on those, can we ask you right now?
Yes. That's what this meeting is for.
Okay. So some of the stuff like I really got, and then some like example, like I don't even know how you call it. Like when you gave the example of like the 2+ where you said it loses 2 electrons, and then the minus where you said it means gain, I don't know if it was gain 1 electron or just gains electrons.
Okay.
That whole like process, I kind of like I got a little bit lost.
All
and
right.
then
Let me do a sample problem, but here's what I want you all to do. I'm going to use my virtual pen to explain something. Please make sure that you tell me that you can see my screen, okay? I'm sharing my screen with you now.
Okay.
Can you see my screen?
Mm-hmm.
I can't see it.
I
see everybody. Oh no.
Okay. Can you see my smooth draw screen?
Yes.
Yeah.
Okay, good. Now I am going to explain this question to all of you. Whoever's paying attention can get this idea. What Diana asked me was, what did you mean by really positive and negative? I'm going to explain that and explain it in the context of the periodic table with a few examples, okay? Maria, right?
Yes.
Maria, okay. So when I said, okay, positive ions, okay, are known as, let me get my pen, I think it's too big to a point where I don't think you can really make sense of it. So let me get my pen and
Isn't working like he's saying.
Can everybody see my screen well?
Yes.
Okay. This is why I wanted to do this meeting, because no matter how much you watch videos, or you have to ask questions to really make sense of it. Okay. So what I understood her question, and I think what she was asking was, how do you make sense of this? Okay. Remember I said in my week 1 video, that's why I said you should all still go watch my week 1 videos, because metals, okay, let me give you the general view here. Metals lose electrons, okay? And you can also blame the chemists why they deviate from everyday way of using things. In chemistry, when you say lose, it's positive, okay? Okay? In non-metals, typically, I am saving this so you don't need to worry if you didn't write any notes, but you can also write notes. And this is not how we use science in our daily life, okay? In our life, when we say we gain money, we use positive. When we say we lost money, we use negative. But chemists want to do things, everything differently from the rest of the world, okay? So lose electrons is positive, gain electrons are negative. And I told you which ones are non-metals also in my
Ow, I was just listening.
These are the non-metals: carbon, nitrogen, oxygen, phosphorus, sulfur. I'm just writing a few: chlorine, bromine, iodine. Okay. Now, as we are doing this session, I will also throw questions back at you, and I want you to be ready. And whoever has the answer can shout out and say, hey, that's the answer, okay? But make sure you have the periodic table with you. The one I posted on the Moodle shell, that's what you need. If you don't have it handy, that's okay. But if you can have access to the periodic table, please have it. Now, what Maria asked me is, I do understand, but she also doesn't understand a couple of things. All right, let's pick sodium, okay? Can someone tell me what the periodic table of sodium is? It's 11, right?
11.
It's 11, yeah.
All right. And can you tell me what column it's under?
1A.
Okay, please tell me the Roman numeral, okay? It is 1A, right?
1A.
All right. As I pointed out repeatedly, I guess some of you may have questions with this, because all this is addressed extensively through the 12 videos in week 2, okay? So I highly recommend after our session today, you start week 2, okay? Don't worry about week 1 homework or quiz, it's over, but I still want you to watch videos for week 2. All right, we know sodium is a metal, right? And if you watch week 2 and videos, and all this is explained, what this Roman numeral tells you is how many electrons, okay? How the Roman numeral tells you how many maximum electrons that element can lose, okay? Now, whether it loses or gain has to do with whether it's a metal or non-metal. Metals always lose, okay? Non-metals always gain. That's usually the trend, okay? Metals never gain and non-metals ever lose, okay? Does that make sense?
Yeah.
Okay. So if this is sodium and it's got 11, and you all probably got this idea from week 1. So how many electrons does sodium have?
11.
11 electrons, right? And 11 protons, right? Now, the valence electrons, now again, I don't want to dwell too much because I want you to also watch the video, but all this is explained in week 2. So you have Roman numeral of 1A. That means sodium can only lose 1 electron. That's it. That's it. It cannot lose more than that. Can only lose 1 electron. Okay, now you can ask me, how do you know it's loose? Because I clearly made the connection that loose metals lose electrons, non-metal gain electrons. Sodium is a metal. Okay, now, so it can only lose. So that means when it loses electrons, how many does it lose? It can lose 1. And as I said, when it loses electron, it gets a positive sign. This is what I was referring to, Maria.
Oh, okay. Okay.
Now, all this is explained with multiple examples in week 2. Starting week 2, with 12 videos or whatnot, it's there in week 12. Every possible scenario that student would make mistake is explained. Okay?
Okay.
Now, this is how many electrons does it have now? When it makes sodium plus 1. It'll make,
It's 12.
10.
no, lose
Oh, 10,
means
it
it lost
loses.
electrons, right? 10 electrons and 11
yeah.
protons, right?
Yeah,
Is
that's
everybody good with that?
Wait,
Yeah.
what'd you say?
Okay.
losing some electrons.
Let's do one more. Can someone tell me the the atomic number of calcium in your periodic table? Is it 23?
20.
20? Okay. And what column is calcium under?
2A.
2A, very good. So how many electrons can calcium lose?
2.
Maria, how many electrons can calcium lose?
So that's 2. So it's a non-metal, right?
No, calcium is a
No, it's
metal, right?
Never mind. So
Okay,
it loses.
everything on the left side into the middle and almost to the right side is a metal, okay? If you again watch my video, pretty much 90% of your periodic table is non-metals. That's why I wrote a few that are specifically non-metals, okay? If you don't see these on the list, it's most likely, again, let me add a few more if you want. These are non-metals, okay? These are non-metals. I've given you a comprehensive list. You don't need to even remember these since you guys study from home.
Okay.
The test. I don't want any of you to memorize it because keep in mind you're in an online environment and there is no question of you ever leaving the book or notes, right?
Mm-hmm.
These are your non-metals. If you don't see calcium on that list, then it is a metal. Okay.
Okay.
So how many can it lose?
So 2 because of the Roman number
Okay,
2.
so how do I write the ion for it? It has lost 2, right? And it's
2.
lost electron, so it's plus.
2 plus.
Okay.
Does that make sense?
Yeah.
Okay, so how many electrons it has now? It started with 20. How many does it have now?
So it lost. So it's 18.
18.
Very good. 18 electrons. The proton count stays the same, right? All right. Now, let me go to a new screen and show you something else that Maria asked. All right. Now, Maria, if you remember, I wrote nitrogen on the list of non-metals, right?
Yes.
So non-metals, they gain, okay? And where do they gain or how much they gain? It depends on, okay, where is nitrogen on the periodic table? Can you tell me the Roman numeral for it?
It's
5A,
5.
right?
5A. Mm-hmm.
Okay. And as I explained in my week 2 video, okay, there is a magic number called 8A. What is 8A is octet, okay? Means it's called 8 is a magic number because that accounts for stability, okay? You may ask, hey, why is 8? Means 8 is known for its stability, okay? And we always lean towards stability in things in life, everywhere, right? So nitrogen's 5, right? The key here is you got to remember whether it's a metal or non-metal. Okay, nitrogen is a non-metal, so it will not lose. It can only, what does it do?
Okay.
Right? How many will it gain? Well, it always have to do with where it is and how much it needs to get to 8. So it is at 5, right? It's got 5 electrons. Okay. What does 5A really means? It's got 5 valence electrons. Okay. How many will it need to get to 8? Just
3.
3 more, right? Right?
Yes.
Go from 5 to 8. Think of this 8 as 8 electrons, okay?
Okay.
Think of the 5A as 5 electrons. So to go from 5 to 8, how many does it need?
3.
3.
3
right?
electrons.
So this is what you are referring to. So nitrogen, you write the symbol. And how many, if nitrogen were to go from its element to an ion, this is an element, okay? This is not an ion.
Okay.
This, however, is an ion. And how do you know how many will it gain? It cannot just gain as many as it wishes, okay? Non-metals are very, very finicky, okay? It does not take whatever it can get. It wants a certain number and it will not settle for anything less than that, okay? So how many can nitrogen gain? What does it need to go from 5 to 8?
Three electrons.
Okay, so 3. And when it gains, what's the sign?
Minus.
That's it. This is what I was referring to in my video, why it's N3 minus. Let's do for oxygen. Which column is oxygen under?
Is it 6A?
6A, right? How many does it need to get to that stability of 8A? 6 to 8. How many is it?
2.
2, that's right. So how many can oxygen gain? Go from an element to an ion. How many can it gain?
So 2, no? 2 electrons?
Yeah, 2. And when it gains, what's the sign?
Minus.
Plus. No?
Minus, right?
It's a non.
Plus is for lose, minus is for gain, right? That's not how we do things in daily life. When we lose money, we say, I lost money, and it's negative. When you gain money, it's positive. Chemists don't work the same way as the real people. So let me give you all a couple of examples, and you can tell me the signs for it. Sulfur,
Can't concentrate.
Cl. I want you to practice it right now and tell me what are, when these elements become ions, what is the number and the sign. Go ahead and practice these and tell me. I'll give you like 30 seconds. All you need is your periodic table, and it will all make sense by the time you get to the end of week 12 video. All this I've just said will make sense.
You promise?
All right, let me ask one person at a time. Lowell, can you tell me what the number and the symbol for sulfur?
It's S and it's 6A. Is that right?
Yeah, 6A, right?
Yes.
Okay, so how many does it need to get to 8?
2.
2, right?
Right.
So when this is sulfur in its elemental form, okay, what would sulfur ion look like? Just look at the screen that what we have done. How many does it need to go from 6 to 8?
2.
2. When it gains electrons, what's the sign for it?
Loses, so it's a negative.
So this is an element, this is an ion. There's a difference of day and night between the two. They're not the same. Okay?
So how are they used?
Okay, that's the next thing, okay? You got to continue watching the week 2 video, okay? We are not in week 2 yet. I don't want to tell you a few things because if I tell you now and the way I have my tone, my voice appears in the video, that itself could lead to some confusion for you, okay?
Okay.
That's the most advanced question you just asked me. That's like week 4 or 5 question, okay? All right. Let's go to the next person. Maybe Diana, can you tell me when F becomes an ion, what do you think it will look like?
So 7.
Okay, so when this is 7A, so it has to go to 8. So how many electrons does it need?
2.
7 to
6
8.
go to 8?
Yeah.
Oh, it only needs 1.
Yeah, that's right. So 1, and then when it gains electrons, what's the sign?
When it gains, it's minus. 1 minus.
That's correct.
Okay.
It just needs practice and some understanding. Actually, I would say more understanding and less memorization. Because chemistry is a science. You don't need to even memorize it. If you understand it once, it will always be the same idea. I don't think it will change much. All right, Maria, can you tell me when Cl becomes an ion, what would it look like?
So that would be, so it's 7. So
Okay.
it needs 1 more.
Okay.
So it's, you will write it as 1 negative.
Very good. That's it. Who wants to answer phosphorus? I'll leave this open. Whoever is shout out there can shout and tell me the answer.
3 negative.
Very good. What do you see is common? There's a pattern on the screen. Can someone decode that pattern for me? We got a bunch of elements on the screen. What do you think between the elements and the type of ions they have? Do they change? Where they are in the column in the periodic table? Where is nitrogen and phosphorus? Are they in the same column?
Yeah.
Okay, and what does nitrogen have? 3 minus, right? Phosphorus is also 3 minus. We did oxygen and sulfur in the same column. So elements in the same column can only gain or lose same amount. That's the rule of thumb here.
Okay.
You see F minus and Cl minus are in the same column. These two are in the same column. These two are in the same column. That's how easy chemistry is if you understand it. You don't need to memorize it at all. And that's why I make the videos, because memorizing chemistry it's probably not going to help you at all. It may help you maybe once on a quiz or a homework, but try to memorize the entire chemistry course is not going to help you, because you will not remember everything.
Okay.
So how does phosphorus get to be a 3 minus when it was in the 5A column?
What's that?
How does the phosphorus get to be a 3 minus when it's in the 5A column?
Yeah, because 5, it has to go to 8, right?
Oh, the 8.
It always has to get to this 8. Let me draw it in red so some of you can see it.
Okay.
This is a magic number. All non-metals have to get to 8.
Okay, that's
This
what
is only applicable to non-metals.
Okay.
Everything you see on this current screen are all non-metals. This stability rule only is applicable to non-metals. It is not applicable to metals at all.
Okay.
Even though metals make majority of the periodic table. Now let's quickly answer something that Lobo asked. Okay, where does this become useful? Okay, which takes us to the next screen. Lobo, you all know sodium chloride, right? Okay, and I've answered all these in my week 2 videos thoroughly. I swear I did, but that's a very good question. I learned these ions, but where does it make sense? All right, Lowell, you're gonna help me walk through this whole problem, okay? Because that's your question. You take rights for it and help me out, okay? Because I thought I imagine I forgot chemistry now, okay? And you are the expert, okay?
You're in bad trouble there.
All right, sodium is
It's
in
11.
column 1A, right?
1A.
So how many electrons can it, will it lose or gain? Tell me that first.
Gain.
Gain or lose?
Sodium is
It's a metal, right?
it's a metal, right?
So will it lose or gain?
They lose.
Okay.
But
And
it's
how many will it lose?
1.
Very good. So am I correct with the way I wrote my ion?
Yes.
Okay. You're going to help me further. Cl, is that a metal or non-metal?
It's a non-metal.
Okay. And how many will it gain?
1.
Okay. Did I do that right?
Yes.
Okay. Now I'm going to switch colors. Okay. To make sodium chloride. Okay. Sodium +1. This is the compound formula. Okay. These are the ions. This is ions. This is the formula.
I can't. If I want, but see what's.
I'm going to write this actually in different colors. Let me get rid of this. Okay. Maybe in blue. Just for time being, I just got it to get it to different color so that. so that people can see it better. Okay. All right. So Cl 1 minus, right? Whenever you have two ions, you have to figure out the formula for it. Again, this is addressed also in the videos. All you have to do is bring the one over here and the one over here. What it tells us is,
I think it's school class.
so technically this is what we will have, right? Whatever's on the top, you bring the number to the end of Cl and the one here, okay? But when it is 1 to 1, we don't really write the ones there. We simply write the formula itself.
Hush.
Does that make sense?
Mm-hmm.
These are the ions, okay? When ions combine, you make a compound, which is your formula for sodium chloride, okay? But let's do a different example. I'm going to do just a different example. Again, all this is explained in week 2 videos. So yes.
So Professor Kumar, so on week 1, you were talking about atoms, and
Yes.
on week 2, you talk about ions.
Yes.
Okay, because I haven't watched video 2. I'll start watching them tonight.
Yeah, that's why I don't want to dwell too much into it, because it's going to confuse. I want you to experience it yourself first, and then we can have one more session like this throughout this course, so that every Saturday we can meet and you can ask me your questions. That way you can get immediate feedback and help. Okay?
Okay.
All right. Let's move on to a different person. Does anybody else have questions on anything that you didn't understand, even on week 1 that you have tried, probably not sure? You can ask.
Let's see.
I got confused in the difference in the terminology going from, well, and I know valence electrons are going to be in week 2, right?
Yes, yes.
Okay. Let's see. I did okay on the electron configuration, but oh, and the orbital diagrams.
Okay.
If you have like a P on, like on the,
Again, Lowell, that is supposed to be in week 2. There is a video for it in week 2 as well. That's why I said we're not going to really grade homework 1 or quiz 1 all that much with seriousness. I'm not going to put that much emphasis on the work that you submitted. I'm only going to probably grade the ones that are associated with week 1 videos. Okay.
okay.
Again, I apologize for that homework issue. That's what probably caused the confusion. But otherwise, everything else is in the same place and it has no issues at all.
I have a question, like we're talking about week 1.
Okay.
Some of the videos when you were doing like a diagram of, the nucleus and then the orbitals.
Okay.
So my question is, if I understand, this is how I understand. So, okay, so the orbitals go around the nucleus, and then within each within each orbital, each circle, there's 2 electrons.
Yes. Yes.
Okay, and so my question is, there's always 2 electrons on each orbital.
Yes. Okay. Now you're asking 2 questions. Okay. Let me delete the screen right here, and then it's all saved. Okay. I have saved it. It may not be saved to you. Okay. So now what Diana, what you asked me are 2 different questions. Okay.
Maria.
Oh, Maria. Sorry. I keep.
It's okay. It's okay.
What you asked me are 2 different things. Okay. Now the S orbital can hold 2 electrons, right?
Mm-hmm.
How many can P hold? I think I've explained that.
6.
6. How many can D hold?
10.
How many can F hold?
14.
Very good. Okay. Now what I explained it is up until the end of week 12 is where I think I've answered the second part of your question. So if this is your nucleus, which contains your protons and neutrons, right? Right? The way I explained it in week 1 and into almost week 2 are, I've drawn 2 different types. Okay, the first one is, let's pick an element. Let's pick again sodium. Okay, right? And what's the orbital sequence? I mean, I think again this is all part of week 2. Okay, but I'm going to explain it so it will make sense. Okay, 1s2, 2s2, 2p6. Okay, please use for the orbital sequence, please use that image file that I uploaded. It says periodic table orbital sequence or something like that. Okay, please use that. Okay, if you use that, you will notice that sodium is 11, right? So it has 11 protons and 11 electrons, right? To write orbital configuration, we only use the electrons, not the protons. We never worry about protons because it's like at the Earth's core. It's very difficult to remove protons. It's not that easy, okay? All right? So sodium is 11, right? So how many electrons do I need? If you follow the orbital sequence, I said S can take 2, P can take 6, 10 can take 14, and D can take 10, and F can take 14, right? So you start always filling from the left to the right. So the S can take 2, right? This is S, it can take 2 more. So we have 4, we still need 7. So I put 6 in P, all of it. That means I'm left with 1, right? This is what I was explaining in week 2. Now, when you go to draw it, let me get a different color because I do want to use a different color here. So I am not going to complete the entire circle. As you've seen, I'm terrible in drawing. So 1S, okay. This is 2S, right? This is 2P, and this is 3S, right? Right? Now, what I asked by orbital diagram is slightly different, and I answered that in the end. I think it's week 2, 12th video. Okay, this is one way of writing it, which is you just put. I mean, if you draw it a full circle, which I think I am going to give it my best to draw circles. Okay, this is 2 electrons, right? So I put 2, right? This is still S orbital, right? Again, it doesn't matter where you put it. This also has 2, so 2, right?
Okay.
And P is
6.
6, so draw 6 electrons. It doesn't matter where you put them, just put them. And if you ask me, why do you say it doesn't matter? Because it does not matter. That's the answer to that. Okay, and then 3S is 1.
Oh, okay. So now I understand, because I was thinking that it was like a rule, like each orbital had, 2 electrons, but now I see that it goes based on each little bracket of the electric configuration.
Configuration, yes.
Okay.
Now, this is the fundamental electronic configuration, okay? Something you will learn in week 2. I don't want to say that now. This is the fundamental electronic configuration, okay? There is one other way of writing it, which I have explained it at the end of week 2, okay? This is the fundamental. If you learn this, if you have no problem with this, then learning the alternate version is not difficult. If you don't understand this, then please tell me. I will explain it with a different element again. If you don't understand what I just wrote, again, if you follow the sequence that's in that picture, you would be good, okay? So let's get maybe a different element. And someone can give me their favorite element from the periodic table.
Yeah.
Christy, you have a favorite element?
Gold.
Gold, all right. Let's go for it. AU, right? Can someone tell me what the periodic, the atomic number of it is?
79.
What is it?
79.
No, 79 might be the atomic mass. Is it atomic number? Is that what you're looking at?
Atomic.
Yes.
Okay.
Atomic number.
Let me make sure that, yes. Diana said the atomic number is 79. All right. Right. Now, if you are all looking at the periodic table sequence, does anyone have that with you?
Yes.
If you have not downloaded, I think I have an image of it. So let me go get that. Documents. Okay, this is what I was talking about. Maybe I'll just show you so you can see it. It is in week 1. Has anyone seen this one? If you go to the week 1 folder, you will see that there is a file called periodic table orbital sequence or something like that. It's an image file. Okay, does everyone see what's on my screen now?
No.
Yes.
Christy, can you see it?
Yeah, I could do.
All right, so let me go back to the screen. Now, while I have this, I'll explain something, okay? Where do you guys see AU? Which row it is in? In the 6th row, right?
1B. Yeah.
It's right here, right?
Yeah.
Okay, so that means we have to follow all that sequence to get there.
Okay.
All right, I know this by heart because I love chemistry, but I don't expect you to know this by heart, at least not now. But hopefully, you know, you will learn to understand how it works, okay? So I'm gonna go back to my smooth draw and draw something else, all right? So let me write out the whole sequence, okay? I don't wanna fill any electrons at this point. I simply just wanna write out the sequence. Just follow the sequence. If you follow it, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and then 4f, right? There's a 4f, right? In between, right? 6s, 4f, right? You all see it?
Yeah.
Do you see my screen now?
No.
No, it lost it.
Lost it.
Okay. Can you see it? Can you see this screen now?
Yeah.
Okay. If you go to the image sequence, you'll see there's a 4F and then finally a 5D. Okay. This is the sequence from that image. Okay. All right. Let me show you. Let me try something, but I don't want to lose the call. Is because of that problem. So can everyone see my screen? What I have now, the sequence?
Yes.
Okay. Now 79 is the atomic number. How many electrons does this element has?
79.
Very good. It doesn't change. That's why I said chemistry is science. It doesn't change because you go to a different element. We have 79 electrons and 79 protons. Now, Maria, can you help us? I will use all your help to fill these electrons, okay? Let's start from left to right. How many can that? We need 79, so obviously, how many can this S have?
So it's 2.
Okay. Okay.
2,
Okay.
2, 6, 2, 6,
Okay.
2, 10, 6, 2, 10, 6, 2, 14.
Okay.
10.
This is where I'll stop.
Oh, yeah.
And then make sure you have, I believe it has 77 so far, if I am not mistaken. If I go to the periodic table, you may ask me, how do I know? I think I have 78 so far, if I'm not mistaken. Does anyone want to count the electrons that's on the top? Count every electron that we filled so far. How many does it have?
70.
70 or 78?
70.
70.
Okay, 70, right? Okay. So how many do I need?
9.
Right?
Where
Okay.
is the 5D coming from?
5D9, right?
Yeah, I don't know where the 5D come from either.
Yeah, because you have like
We missed one. We missed one. What is that we missed? Okay, now let's stop here, okay? Let's not go any further. We got 79 electrons, right? We filled the 79 electrons, right? Now here is the problem, okay? Anytime you have anything past 4s, okay, you have to go and put the 3s with 3s, 4 with 4s, 5 with 5, 6 with 6. Only then, this is not the correct configuration. This is the initial draft, if you would mean. This is incorrect configuration. We're not done yet. That doesn't mean what we have done so far is entirely wrong, but we are not done with our configuration. Does that make sense?
Mhm.
You all have to start somewhere like this, unless you become like me, that you don't need any more help from any of us, okay? Please follow the sequence. Since you're all in the online class, you have the luxury of holding on to this image that people in the inside don't. All right, now does anyone want to help me put the 3s with 3s, 4 with 4s, 5 with 5, and 6s with 6s? Make sure this is the sequence. You cannot bring D before an S. Yes, P, D, F is the energy sequence. When you move things, you cannot bring a D in front of a P or P in front of an F. So does anyone want to volunteer and tell me what the correct sequence would be? You cannot change the number of electrons. Yes, Diana, please.
1s2.
Hang on 1 second. Let me get a different color. All
Okay.
right, go ahead.
1s2.
Okay.
2s2.
Okay.
2p6.
Okay.
3s2.
Okay.
3p6.
Okay.
3d10.
Very good.
4s2.
Okay.
4p6.
Okay.
4d10.
Okay.
4f14.
Okay.
5p6.
Okay.
5d9.
Oh, you missed 5s.
Oh, did I?
Yeah.
Oh, I did. I sure did. So 5s2 comes after 4f14.
Okay.
Then 5p6.
Okay.
5d9.
Okay.
And then 6s2.
Very good. Does everyone follow what I just did?
Mm-hmm.
Maria, were you able to understand what we did?
Yeah.
We just put the like numbers together. Okay. Now, if any of you have paid attention, Diana, since you helped me, can you tell me what is the Roman numeral on top of where AU is?
On top of our AU, it's 1B.
Okay. That means if you followed, I mean, I don't want to say that now, but 1B means you can lose only one electron, right?
Mm-hmm.
The AU is an exception, but I don't want to say, okay, I might as well say the exception since I have you all here, okay? That means it can lose only one valence electron, right? Right? So there is another way to, so that means it can only lose one electron, right?
Mm-hmm.
That means that's why you see gold is always +1. If any of you have seen a gold ion, which you probably have not, even I have not seen one. I've seen gold, but I've never seen gold ion. Okay. This, folks, is the correct configuration.
So I have a question. So when you do the configuration, does it always, all the numbers and letters always supposed to be together? Always, always?
Yes.
Okay.
Like you cannot, when you move around, you cannot just move the 4F. You got to move the whole thing. And yes, they all are together. You cannot separate them out. Just like how Diana told us, that's how it's supposed to be. Does it make sense?
Yeah.
So I have another question. I don't know if it's like a dumb question. So if you're doing, because I would imagine you do these type of configurations with ions too?
Yes, yes.
Okay,
Let's go do one. This is explained in week 2 videos, but since you asked, let's do one example. Okay?
So my question is like, so the rule goes the same where everything that's the same has to be together when you do configurations on atoms and ions.
Exactly.
Okay.
The rules are the same. So
Okay.
why don't we do one example, okay? Let's do calcium 2+, okay? If this is the ion, and I have you write the electronic configuration, okay? Can anyone tell me what the sequence is first? Don't worry about electrons. All right, first let's go back. What's the atomic number of calcium? Isn't it 20 something?
20.
Okay. So Maria, how many electrons does it mean calcium has?
How many electrons? 20.
Okay, good. Right? 20 electrons and 20 protons, right?
Mm-hmm.
When I go to calcium 2+, how many electrons does calcium 2+ have?
I need to see you
Finish.
So that means it loses too?
Yes, yes. So how many does it have? How many has
Oh,
it?
it has 18.
Very good. This is what we started our Zoom session today with. That was your first question, so you cannot forget that. All right, now help me look at that orbital sequence image, or I can write it and you can verify if I write it right or wrong.
Okay.
Is that correct?
don't hear it.
1s, 2s, 2p, 3s, and then 3p,
Okay.
and then 4s.
Is that correct?
Yeah.
Very good. All right. I am going to do two things. I'm going to write it for calcium, and then we can write it for calcium 2+, so you can see how the difference is, okay? All right, Maria, help me fill electrons now. For calcium, not calcium 2+. We have 20 electrons, right?
Uh-huh.
So start filling it for me.
Oh, 2,
Okay?
2, 6, 2, 6, 2.
Right? This is what your question, okay? We can do it for one element where we can shuffle, but what we're really trying to do is, this is calcium. When it becomes calcium 2+, it's lost electrons, right?
Turn it off.
It cannot just lose electrons from anywhere it wishes in the sequence. It can only lose electron from the orbital that's the furthest most from the nucleus, okay? This is where your nucleus is, somewhere here, right?
Mm-hmm.
This is the furthest most, right?
Mm-hmm.
Let me get a different color. If this were to be my nucleus, this is my 1s, 2s, 2p, 3s, 3p, 4s. So this is technically my valence orbital, means the furthest one from the nucleus, right? So when calcium, this is for calcium. This, however, is not the same for calcium 2+. When calcium becomes calcium 2+, I'm going to write it, and then I will do this for all of you. I don't expect any of you to tell me. All right. What we have done is, since these 2 electrons are lost, it becomes technically 4s 0. When electrons are lost, we don't write the orbital if it is empty. Okay? We cannot write it as 4s 0. That is incorrect. This is where we stop, because these are the 2 electrons that are lost.
Okay, does it always lose the one at the end?
Yes, that is the purpose of a valence orbital. Because the closer it is to the nucleus, it is difficult to remove that electron. The furthest away from the nucleus it is, that is called a valence orbital. As you see, I've written it underneath the 4s, the term valence orbital.
So the valence atom is the one closest to the nucleus?
No, atoms, okay, you're confusing me now. Atom contains, okay, if this were to be the atom, it contains the nucleus inside, and it contains the orbitals around. Okay?
Okay.
A nucleus is part of an atom. An atom itself is not a nucleus. Okay?
Okay.
So this is the nucleus right here, folks. Let me get my red color. Every atom has a nucleus, which is right at the core. And then it's followed by orbitals. Okay? And you can only remove an electron from an orbital that is furthest from the nucleus. So I wrote the electronic configuration of calcium, as you can see. But when calcium becomes calcium 2+, it's losing 2 electrons. And where is those 2 electrons lost? It just cannot lose the 2 electrons anywhere as it wishes. It can only lose it from an orbital that's furthest away from the nucleus. That's why I drew that black shaded circle. That's my nucleus. And the 4s2 is the furthest one from the nucleus. And if you see, it's got 2 electrons that it can lose. So when it became calcium 2+, when an element has lost, if it's got 2 and it's lost both, you cannot write it as 4s0. That orbital is of no use to that element anymore, so it's discarded completely.
Okay.
So we just write it without that. Maybe I'm going to give you all one example to practice while I have you here, and I'm going to give you 30 seconds. I want you to use that orbital sequence image, okay? And let me delete the screen. All right, I want you all to practice chromium 3+. Write me the electronic configuration of chromium 3+. Take 30 seconds. You may have to shuffle and all this, and then you also have to remove 3 electrons. And whoever's ready with the correct answer can give me the correct electronic configuration of chromium 3+. You would need your periodic table, and you also need the image. While you're practicing, I'm going to get this image. Okay, this is exactly the image that is posted under week 1. This is what I was referring to. This has got the sequence. So I put it up on the screen for you for your reference if you don't want to go and download it. This image can be found in week 1. I think it's called periodic table orbital sequence. It's an image file. So you have to use the sequence that's shown here, and then you have to correct it and then remove electrons.
Conference call.
If any of you could actually give me the configuration for chromium, I'd appreciate that first. First, give me the configuration for chromium, and then you can shuffle and then do it for chromium 3+.
It's 1s.
Hang on 1 second. Let me erase this. I don't think I'll have enough space if I write it as big now. All right, who's going to give me the answer?
It's 1s.
Okay.
2s.
Okay.
2p.
Okay.
3s.
Okay.
3p.
Okay.
4s.
Okay.
3d.
Okay. All right, now start filling with electrons. What's the chromium's atomic number is 24. So we have 24 electrons and 24 protons. So let's go and start filling these first. You want to fill this first before you shuffle.
Okay.
So it'll be 2, right? 2, 6, 2, 6, 2, and 1, 2, 3, 4, right? That's what we need. Is that correct?
Yeah.
All right. Now, who wants to help me shuffle these and get it into the correct? This is incorrect version. You got to do the shuffling.
We're not.
You pull the electrons before you shuffle.
Yes.
I got it. Okay.
All right. Hang on 1 second, Diana. When I'm ready, you can give it to me. All right. Give it to me, Diana.
One S2.
Okay.
2S2.
Okay.
2P6.
Okay.
3S2.
Okay.
3P6.
Okay.
3D4.
Okay.
4S2.
Fantastic. This is the correct configuration for chromium, but we're not done yet because we're not just writing the configuration for chromium. We are doing it for chromium 3+, right? All right, everybody. If I say 3+ and chromium is a metal, how many electrons has it lost from the total count? It had total of 24 when it's chromium, but now it's chromium 3+. So how many electrons does it have?
21.
21. Very good, right? And I said you got to remove electrons from the furthest orbital. All right, this has got 2, right?
Right.
So that counts for 2 out of the 3. I still need 1 more, right? Where is that 1 more going to come from?
That 3D.
Yeah, this is the next furthest one. Very good. So I am going to write my configuration and then I'll explain one more time what has just happened, because chemistry requires a lot of cognitive load on your brain to understand. You got to be able to process multiple things at the same time, and that is the very difficult part about learning chemistry. Is you got to listen to the instructor, you got to look at the periodic table, you got to listen to what he says. Just too many things. Does it make sense, Maria? Does it make sense, Christy?
Yes.
Yes.
You have to go to the furthest one, remove whatever is available, depending on how much you need. Now, say if it was chromium 2+, okay, then it would be a different scenario, right? You don't need to remove that extra electron from the D. It would have just been 3D4, right? But because we needed 3+, we did this. Okay. Now let's do one more, but this time let's go ahead and write an electronic configuration for N3-. Let me bring my trusty little picture back. Just this is again only for your reference. You don't need to.
No, F. You got too much noise.
All right. Whenever I ask you to write an electronic configuration of an ion, first I highly recommend you write the electronic configuration of nitrogen itself, and then you can go ahead and try N3-. Okay. So first write the electronic configuration of N. You may not have to shuffle. It would normally be perfect if it is. If it is not, if the element is in the first 3 rows, you don't need to shuffle. Only starting the 4th row, 5th and 6th and 7th, you have to shuffle. So the general electronic configuration for nitrogen is 1s, 2s, 2p, 2, 2, and 3, right? Right?
Yes.
Because nitrogen's got 7 electrons because its atomic number is 7. All right, now N3-. Maria, you started this session with the question. N- indicates what has happened to nitrogen. Has it lost 3 electrons or has it gained 3 electrons?
It's gained.
Very good. Right? So same thing as we with removed. when you want to gain electrons or add electron, you cannot just add it anywhere as you wish. You still have to add it to the furthest orbital from the nucleus. And the furthest orbital is this one, right?
Right.
So that means when we write our configuration, we write it as 2p6.
6.
Okay.
Does it make sense?
Yeah.
I think I just literally taught you today in the last hour the entire week 2 material. That's not what I bargained for this session. My session was more about asking questions from week 1. But I have essentially taught you week 2 except video 12. Everything I have told you right until this example is video 1 through 11 in week 2. I have taught you everything, every scenario possible, everything right from the word from video 1 to week 11. There's only one video left that we have not got to yet, and that's video 12. The only thing we have not covered in this session. But it took me 11 videos to record detail, but pretty much in the last hour and last 46 minutes or so, we have covered entire week 2 material. This is what's in for week 2, starting Monday. And the quiz and the homework is open starting Monday morning at 6:30. That's when it will become available. Okay. So quiz 2 available. Let me write this here, Monday morning at 6:30. It won't be available before that.
Okay.
Homework's already available. You may be able to download, but sometimes it doesn't allow you because it's not 6:30 Monday morning. Does anyone have any basic confusions with electronic configuration? You do have to use the sequence that is posted as an image file in week 1, okay? There's an image called periodic table orbital sequence, something like that. This is an image file. This is what you have to use if you want to get this electronic configuration right every single time. If you use, you're welcome to use outside videos. I highly recommend you watch mine first because I don't make mistakes in any of my videos. The content is 100% accurate. That's more important. If you watch other videos and if they have made mistakes, and to my knowledge, there is no such sequence like this. I created this for my classes. You search Google, you will not find a sequence like this anywhere else. You will find something else very generic everywhere, but not what you're seeing on the screen. This is only available to people in my classes.
Okay.
So please use this sequence. Please watch my videos. I'm not opposed to you trying other videos, but watch mine first because it takes a lot of search to find a good video on YouTube. There are a lot of people that probably explain this, but there may be issues or mistakes. What happens when you watch YouTube is they don't shuffle the configuration. They stop where you write the first step and they call it correct. That is incorrect. Okay? If you don't shuffle like we did, you don't have the correct configuration, but people on YouTube say that what you wrote the first time is the correct one, and that is unacceptable and incorrect.
Okay.
Yeah, basically the last hour and 15 minutes, we've essentially finished week 2. Okay? If you have written notes from this, I will post our session today, the Zoom session on Moodle. So you can also go back and watch that, okay?
Okay.
My computer has captured every little teaspoon we have done, you have done, every word you have said, I have said. Everything we have done for the last hour and 15 minutes is recorded. Okay? So if you feel you missed something, before I'll take any last questions, does anyone have any element you want to do in electronic configuration that you probably have struggled with when you did your... So there is one more question I do have on week 2 homework, which is something I've explained billion times in week 2 videos, but I am going to just say it on the screen here. Okay, how many valence electrons are in a element? Okay, in a particular element. I've explained this even today, and I've explained this in the video, which is the Roman numerals. All you've got to look at is look at the Roman numeral. That's all you need. That's an indication of how many valence electrons that element has. For instance, how many valence electrons does calcium have? What's the column number?
2A.
So how many valence electrons does calcium has?
2.
2. Very good. What is valence electron is, Diana, you said calcium's 20, right?
Yes.
So it's got 20 electrons. But like I said, not all 20 electrons can be lost. It can only lose 2 electrons. So calcium's valence electron is 12. How many valence electron does Mn have? Look up Mn on the periodic table. Where is it at? I believe it's 4B. I believe.
Mn?
Yeah.
Oh,
7B.
7B?
7B.
Yeah.
All right, so how many valence electrons does manganese has?
7.
7.
7. That's it.
Ma'am, go out of here.
Oh, you disappeared on us.
So,
Lowell.
yeah, so how many electrodes?
You're not going to Walmart.
Yeah. This is one of the last questions that is on homework 2. Pretty much the whole session that we have done today will be available on Moodle. Okay. And I've literally taught you week 2 material today. Okay. Okay.
okay.
This is the only question that I have emphasized in my week 2 videos, but some people still don't understand it, which is how many valence electrons in an element. Okay. Look at the Roman numeral. Whatever is the Roman numeral, that is how many valence electrons that element has.
Okay.
Okay. Let's do one more, and then how many valence electrons does zinc have? Zn. You got to look at the periodic table. Look at the Roman numeral. I believe it's 2.
2B.
Yeah, 2B, right?
Mm-hmm.
That means it's got 2 valence electrons.
Mm-hmm.
Do not confuse the valence electrons with regular electrons, okay? Regular electron tells you how many total there is. Valence tells you how many can it gain or how many can it lose, okay?
Oh, okay.
And this is a last problem on homework 2, and I believe I've explained it, but I still get emails from some of the students who already started watching week 2 videos. They email me and ask how many valence electrons, how do I do that problem? Well, this is how you do it. I just showed you.
So, on the columns or the groups that are where it's got Roman numeral 8 with the arrows on either side.
Yeah.
That means 8, 9, and 10 are all valence electrons of 8.
Yes, yes, yes. They all have 8 valence electrons. That's what it means.
Okay.
Now keep in mind, non-metals, the Roman numeral tells you how many it needs, right? Only for metals, the Roman numeral tells you how many it can lose, right? That's the first thing Maria asked me today. How do I figure this out, right? So let me wrap it up with the session with, for nitrogen, again, let me repeat, this is what we started the day with. The Roman numeral is a 5A. This is a non-metal. It cannot lose 5 electrons. It has to gain so many to get to 8A, which is a stability factor or octet. Okay, octet means 8. 8A is a stability number. It's a magic number, as some chemists call it. Nitrogen is a 5A. It needs 3 electrons to get to 8. Why do I say 3? Because 5 means 5 electrons. 8A means 8 electrons. So to go from 5 to 3, it needs to gain 3 electrons, which is why nitrogen is 3 minus. And if you apply the same logic that we learned today, oxygen will be 2 minus. Phosphorus would be 3 minus. Okay? The Roman numeral has 2 different meanings depending on whether it's a metal or a non-metal. Okay? Does it make sense to everybody?
Yeah.
Is there an easy way to remember metals versus non-metals?
I think I can probably, well, since you're studying from home, I would just I would probably send you another periodic table that classify them as metals and non-metals.
Oh, that'd be
I'll
awesome.
post another image of it.
Thank you.
I mean,
Okay.
pretty much everything that I gave you. If you don't see this, it's probably a metal. Okay, list of non-metals. I can give you this. If it's not one of these, then it is probably a metal. Okay. I think I gave this list at the start of our session today. Phosphorus, chlorine, bromine, iodine, nitrogen, sulfur, oxygen, and silicon, carbon. I think I got everything, mostly everything. If it's not with, oh, fluorine, sorry, one more. And boron. This is pretty much all your non-metals. If what you're looking at is not in this list, then it's probably a metal. But I will send another periodic table which just shows which ones are metals, which ones are non-metals. You can use that to do. Like I said, homework 2 is tailored to exactly. There's no issues whatsoever with the homework 2 or quiz 2 or videos, none of that. But I still highly recommend you watch week 1 videos for refreshment if you want, but don't worry too much about the homework 1 or quiz 1. Okay? I'm not going to put too much weight on it for grading. But starting week 2, I will grade all homeworks and quizzes for its face value. You do remember you get 3 attempts on the quizzes and 1 full redo available on the homeworks.
I have a question on the quizzes. You had mentioned on your introduction video that like, so you get 3 attempts, that to do 1 attempt and then, so see, let me see if I understand it. So I do 1 attempt on the quiz.
Okay.
And then I wait for you to grade it, and then
it's automatically quizzes or multiple choices. It automatically.
Oh yeah. You're right. So so let's say I do attempt 1 and I get, I don't know, a 60.
Okay.
But obviously I have 2 more attempts. Can I attempt it 2 more times, or do I have to?
Yeah, you can attempt it all 3 times. There is no restriction. You
Okay.
only run out of your attempts after you finish all 3 attempts.
Okay.
But what I suggested is take the first attempt, and if you feel not so confident about some of the questions, shoot me an email and ask questions then, or your quizzes normally due on Sunday midnight. If you have one of these sessions, ask during that time and make the 2nd and the 3rd attempt. So you're not just wasting attempts for, that's what I mean.
Okay.
But you don't need, you feel, oh, I know what mistake I exactly did, and you can go back and attempt it right away. There is no time frame. Like you cannot, these people set like a 30-minute break before you can attempt the 2nd time. I didn't even do it. You can do all 3 attempts in one go if you wish, but that beats the purpose of giving 3 attempts. Is I want you to do well, but if I just give you 1 attempt, then you're not going to, say you get, like you said, you got a 60, you're stuck with that 60.
Okay.
But if I give you 3 attempts, you have an opportunity on the 2nd and the 3rd attempt to go get that full score. And I know with nursing programs, it's all about points. And you want to get every point possible.
Yeah.
Not lose anything. Now, this is not because nursing or whatever. I always did 3 attempts on quizzes and homework 1 attempts. Because at that point, I'm giving the student the opportunity to learn something rather than saying, you're stuck with this point, just live with it. And I don't like to do that. Any other questions, guys?
One question. On the homework, there was something about how many p electrons are in an atom or an ion.
What I was really referring to was, let me write this. Let's just write a sample configuration. So what I was really referring to, again, that whole mess up happened because of that video confusion. Otherwise, none of this would have really happened. Let me get my, let me erase what I was writing on screen. Okay, so what I was really referring to was, let's say we have nitrogen and it's 7, right? And write the electronic configuration is 1s2, 2s2, 2p3, right? What I meant to say was how many p electrons are in the furthest most p orbital in that sequence, okay? So how many electrons are there here in the p orbital?
3.
That's what I was referring to.
Okay. That's what I thought. I get it, but
I'm not even going to grade that question because technically all this is part of week 2 material.
Okay.
So even if you understood it, it's unfair for me to grade it.
Okay.
So
Yeah, I got it wrong, so I misunderstood.
I mean, almost 60. I'm not going to grade more than 65% of homework 1 problems. Okay, I'm just not going to do that. I'm only going to grade a couple of problems that are directly related to week 1 video.
Okay.
Don't worry about the homework 1 or quiz 1 as much. Okay. From now on, you got to do well on every quiz and homework because I made sure there are no surprises, no issues whatsoever. Again, I tried my best, but I don't know how it beat me into that being screwed up like that. That's the first time this has happened to me. That's why I was really confused. Like normally I don't do those kind of mistakes in class. Everything is done to the T correctly for that class. So unfortunately, this is the first time I have tried this particular technique full on for a full 8-week course. I have done this online videos before, but I've done it for 4 weeks. But this is the first time I'm experimenting for all 8 weeks. And I still think you get better view of chemistry over just reading a textbook. That's how it was. I think you would have really been lost completely. There was no way you're going to read 40 odd pages in 1 week, do a quiz and a test, and it's just impossible. Basically, there is no there's no need for Zoom sessions or no need for videos, none of this. This is primarily my interest to do it. All the earlier structure was, it was like a buffet. You go in, help yourself, and take the quiz when it opens up. There was no way you are going to get that. I mean, with me here, if writing configuration is this hard, imagine yourself reading about it for 40 pages. Do you agree with me? Like with me being here, seeing on a webcam, you find it hard to learn. Then imagine yourself picking up that electronic book and start reading those pages. Again, they didn't give the entire reading material. They told you read sections this and this from the book. It's not going to be that easy. There's a problem with not just any of you, but most people that learn chemistry is they cannot translate what's on words to pictures in their mind. It is not easy transformation. People see chemistry visually, but they cannot make that visual connection from reading a textbook. They just can't do it because it is so abstract that you want somebody to tell you, hey, this is how it works. And without that connection, to read 40 pages in a textbook and translate every single word into a picture in their mind, very, very difficult. So hopefully you got something out of this session. We're coming to the end of this. Every little keystroke has been recorded. So I'm going to post this whole video session on Moodle. So if you have a doubt on some of the same questions you asked me, all you got to do is play the video. This video will be posted under week 2. Okay?
Okay.
Thank you very much for doing this.
Yeah, thank you.
Thank you all for taking your time to show up on a Saturday evening. Enjoy the rest of your evening, and I'm going to sign off here. And if you have questions before our next session, just send me an email. That would be the easiest way to get hold of me. And Lau, I don't think is there an issue with your Lowell? I replied to you, but it came back to me. It said message not delivered.
I don't know.
If you have time, call the IT people on Midway Monday and ask the instructor tried to contact me, but the image was the email was sent back to him saying email not sent. That was the email I got today. Okay, I replied to your email, but it came back saying message undelivered. So
Okay.
you may want to call IT and ask why it happened so we can fix it. Okay.
Okay, thank you.
Because it's important. That's our only primary communication.
Wait.
We don't want to mess it up. Okay.
Thank you.
All right, everybody. Take care.
All right, you too.
Thank you.
Then watch the video and watch week 2 videos. Watch all 12 videos. Every single homework problem is tied to every single video. So all you got to do is watch one video at a time and solve the problem. It's just
Okay.
simple.
Thank you.
All right.
Okay,
All right.
thank you so much.
Thank you.
Bye.
Bye. It has been a nice time meeting them, right?
How do you close out? I got a leave meeting. There we go.
It has been nice.
Can I do this?